Okay, so I see factorials in here, so let's remind ourselves about factorials. So remember 5 factorial is 5 times 4 times 3 times 2 times 1, right? 5 factorial can be written as 5 times 4 factorial. So in the same way, n plus 1 factorial can be written as n plus 1 times n factorial. Okay, so that's going to come into play, as you can well see, right? Got them things in here. Okay, just wanted to go over that. All right, let's get rid of that so I have room, because these induction proofs, they take a little space now, don't they? All right, so let's dig in. So, prove using induction for n's bigger than or equal to 1. So let's show true. So make sure you're writing these words, right? I'm showing true, for n's bigger than, or it does say equal to 1. Okay, my little line there went closer over it. So n equal to 1. So I want the sum from I equal 1 to 1 of I times I factorial. So if I plug in 1 here, I get 1 times 1 factorial equal, so I'm plugging in 1 on the right hand side, so I have 1 plus 1 factorial minus 1. So this gives me 1, this gives me 2 factorial minus 1, that's 1, check. Okay, so I want to assume true for n equal k. So the sum from I equal 1 to k, I times I factorial equal k plus 1 factorial minus 1. Okay, so I want to show true for n equal k plus 1. So I equal 1 to k plus 1, I times I factorial. And I'm going to be putting in k plus 1 on this side, right? So I have k plus 2 factorial minus 1. All right, so remember with these summations up to k, I need to break off. So if I'm adding all the way up to k plus 1, I want to break off the first k of them and add on the k plus first, right? So let's break it up. So I equal 1 to k, I factorial plus, and now here's my k plus first term. So that's k plus 1 times k plus 1 factorial. Okay, so this here, I use my inductive step, right? So this is this step right here, right? So I'm substitute this in. So I have k plus 1 factorial minus 1. And then let's bring this guy down. So plus this, k plus 1 factorial. Okay, again, you don't move this side. Don't use this and move things to the other side. I want to get to this, right? So I'm just going to write it down here. So I'm thinking, how am I going to get this to look like this? That's my job, right? So, I see this k plus 1 factorial that is in common only between these two. And this minus 1 has to stay off to the side, right? It does. So what I'm going to suggest we do is just move this negative 1 over here. I'm going to carry this one along. And I'm going to take the time to distribute this k to this and then 1 to this. So I have plus k times k plus 1 factorial plus 1 times k plus 1 factorial. Okay, what do I have? Oh, I've got 2 of them, don't I? So I've got, and I factor out a k plus 1 factorial out of all of these. So if I do that, so let's do that. So k plus 1 factorial times, so if I factor this out of this term, I'd get a 1. If I factor this out of this term, I'd get a k. And if I factor this out of this term, I'd get a 1. And again, I'm carrying that negative 1 off to the side. Oh my goodness, what do I have in there? So I have k plus 1 factorial times, this gives me k plus 2 minus 1. Wait a minute. Don't these two combine to give me k plus 2 factorial? It does indeed, right? Just like n plus 1 factorial is equal to n plus 1 times n factorial, it's true, k plus 2 factorial would be k plus 2 times k plus 1 factorial, correct? And that's what I have. And I've got there.